This is your video for lesson 6 on page 51 in your textbook. The lesson is scientific notation. So let's get started on the guided practice questions. Okay, so if you look at the guided practice questions, number 1 says, write each number in standard form. Okay, so when we write it in standard form, our question will have it in scientific notation. Remember that if it's in scientific notation, it's going to have times 10 and then an exponent here. So times 10 to the 5th power, times 10 to the negative 4th power. Okay, so this is called scientific notation, and if we want it in standard form, we want to move the decimal so that it does not have this times 10 to the 5th anymore. This is scientific notation. This one would be standard form. Okay, so on this one, because the exponent is bigger than 0 or bigger than 1, that means that we're going to make this number into a bigger number than it already is. And so the decimal right now is 9.9. And so since it's a 5, we're going to move the decimal place to the right 5 times. So we're going to move it 1, 2, 3, 4, 5. And the decimal would end up being right here. But notice that we don't have any numbers for these two blanks. Okay, so we have a 9, a 3, a 1. But the two parts that don't have a number, we would put zeros. Okay, so then our answer in standard form would be 993,100. And we can check our work too by going backwards. If the decimal place is here, moving it over 1, 2, 3, 4, 5, we would get our same answer to begin with. Okay, so if we try the next one, our decimal place is here, but notice that our exponent is negative. So if the exponent is negative, we want to make it a smaller number, and so we're going to move our decimal place to the left. Okay, so we're going to move it 4 times because it's a negative 4. So we're going to go 1, 2, 3, 4. All right, there's 1, 2, 3 places where there is no number. So I'm going to put 1, 2, 3 zeros and then 6, 0, 2. Okay, so I'm finished here again, and I can move it 1, 2, 3, 4 and get my original answer here. So this is standard form. If they give us scientific notation and they tell us change it to standard form, we would move the decimal place and get rid of the times 10 to the something. All right, these ones want you to write each number in scientific notation. So if I don't see a decimal, which I don't, there's no decimal in this problem that I can see, the decimal place is at the end. So I'm going to put my decimal place, and I want to move the decimal place so that there's one number, then the decimal place, and then the rest of the numbers. So remember on this one, it said 9.9, so the decimal was right after the first number. And on this one, the decimal was right after the first number also. That's how we write scientific notation. So on this one, I'm going to move it until I am next to the 8. So I'm going to move it to there. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9 times. My answer then would be 8.785 times 10 to the, this would be a positive 9 because this is a very big number. So this number is bigger than 1, which makes it a positive exponent. And this would be my answer in scientific notation. This one is a small number. It's smaller than 1. So this one will have a negative exponent like number 2 up above. Okay, so we're going to just move it 1 time because, again, we want the decimal place right after the first number. So my answer would be 5.24 times 10 to the, I only moved it 1 time, and so it would be to the negative 1 power. Okay, number 5 says the table lists the total value of music shipments for 4 years. List the years from least to greatest dollar amount. So they have the numbers in scientific notation. The bigger the exponent, the bigger the number. Okay, so these two are clearly the biggest numbers because they're positive exponents, and 10 is bigger than both 7 and 6. But since they're the same exponent, we also have to look at the numbers. 1.22 is bigger than 1.12, and so this one is the largest. And we want to do from least to greatest. So this one would be the biggest. That would be our last one. This one would be the next biggest. And then 7. And then 6. Okay, because I want it from small to big or least to greatest. My smallest is the 6. My next is the 7. And then 1.12 is smaller than 1.22. So our order here goes this one, this one, this one, and then this one. So in my answer here, I would put year 3, year 4, year 2, and year 1. Okay, and then the last one here says a plant cell has a diameter of 1.3 times 10 to the negative 8th power kilometers. Is it more appropriate to report the diameter of a plant cell as 1.3 times 10 to the negative 8 kilometers or 1.3 times 10 to the negative 2 millimeters? Okay, now we're talking about a plant cell, which is very, 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 very tiny. Okay, so if we're reporting, we want to make it a tiny number or a tiny unit. Millimeters are much, much smaller than kilometers. We drive with kilometers. Millimeters are very, very tiny. And so this one would be, excuse me, more appropriate to report in millimeters than in kilometers. We want as small of an exponent as we can get. So we would write millimeters because plant cells are very small. And millimeters are smaller than kilometers. Okay, and that would be an okay explanation for that. Or I could also say, because I want a smaller exponent, millimeters would be a better representation. And that would be it. So if you will make sure that you have completed page 55 and page 57 for extra practice if you need some more extra practice. And leave a comment if you would like me to post any of the answers to those just to check your work.